Welcome to Astronomy Daily with me, Anna, bringing you the latest space and astronomy news. Today, we have an exciting lineup of stories from across the cosmos. We'll be exploring massive magnetic tornadoes on Jupiter that are spawning Earth-sized storms, learn about some close calls with space debris at the International Space Station recently, dive into groundbreaking asteroid research, and much more. Let's get started with today's space headlines. Planetary scientists have made a remarkable discovery on Jupiter: enormous magnetic tornadoes that are creating storms as large as our entire planet Earth. These massive storms manifest as dark oval shapes in Jupiter's atmosphere. But here's the fascinating part: they're only visible when viewed in ultraviolet light. The discovery came after years of observations, including data from the Hubble Space Telescope and NASA's Cassini spacecraft. These mysterious dark ovals are actually dense hazes of aerosols in Jupiter's stratosphere, formed by swirling magnetic vortices that twist down from the planet's ionosphere into its deep atmosphere. The key to understanding these storms lies in the powerful magnetic interactions happening around Jupiter. The planet is surrounded by something called the Io plasma torus, a donut-shaped ring of charged particles spewed out by volcanoes on Jupiter's moon Io. When these particles interact with Jupiter's magnetic field, they can trigger the formation of these massive tornado-like structures. These magnetic tornadoes take about a month to form and then dissipate within a couple of weeks. The resulting haze in these dark ovals is remarkably dense, about 50 times thicker than typical concentrations in Jupiter's atmosphere. It's as if Jupiter has its own version of Tornado Alley, except these storms are large enough to swallow Earth whole. The International Space Station has had to take evasive action twice in less than a week to dodge dangerous space debris, highlighting an increasing challenge in low Earth orbit. The most recent maneuver happened Monday morning when a Russian Progress cargo spacecraft, docked to the station since August, fired its thrusters for about 3.5 minutes to move the ISS clear of an incoming piece of space junk. This came just 6 days after a similar maneuver was needed to avoid a fragment from a defunct weather satellite. The growing frequency of these avoidance maneuvers points to an increasingly crowded orbital environment. There are currently over 10,200 active satellites in orbit, with SpaceX's Starlink constellation accounting for about 6,700 of those. But the debris problem is far more extensive than just active satellites. Experts estimate there are around 40,500 tracked pieces of debris at least 4 inches wide, over 1 million pieces between 0.4 and 4 inches, and an astounding 130 million tiny fragments at least 1 millimeter in size. Even these smallest pieces pose a serious threat, as they travel at speeds around 17,500 miles per hour at the station's altitude. To put this growing hazard in perspective, the ISS has had to perform 32 debris avoidance maneuvers since 1999, with the frequency of these events clearly on the rise. Speaking of avoiding things in space, in an exciting development for planetary defense, scientists have unveiled a new integrated approach for studying near-Earth asteroids. This breakthrough was demonstrated during the observation of asteroid 2022 WJ1, which was first detected by the Catalina Sky Survey in Arizona last November, just hours before it entered Earth's atmosphere over southern Ontario. For the first time in history, astronomers were able to track and study an incoming asteroid in detail during the brief window between its discovery and atmospheric entry. Using the Lowell Discovery Telescope's rapid tracking capabilities, researchers observed the asteroid for about an hour before it disappeared into Earth's shadow, moving at an incredible 5 degrees per second across the sky. The combined data from telescopic observations and fireball cameras allowed scientists to determine that 2022 WJ1 was a silica-rich object just 40 to 60 centimeters wide, making it the smallest asteroid ever characterized before impact. This precise size calculation was possible thanks to measurements of the asteroid's reflectivity as it approached Earth. This new methodology of combining space-based detection with ground-based observation provides unprecedented detail about incoming asteroids and represents a significant advancement in our ability to study these objects. The success of this approach suggests we'll be able to gather even more detailed information about future Earth-impacting asteroids, enhancing our understanding of these celestial visitors and improving our planetary defense capabilities. And a little update. Earth has bid farewell to its temporary companion, as asteroid 2024 PT5 has officially ended its brief stint as our planet's second moon. The 37-foot-wide space rock, which had been orbiting Earth since September 29th, departed on Monday at 10:43 a.m. Eastern Time. Scientists who track this celestial visitor say it's been a fascinating opportunity to study these temporary orbital captures. Dr. Carlos de la Fuente Marcos of the Universidad Complutense de Madrid, who helped discover the asteroid's mini-moon status, explains that 2024 PT5 is typically part of the Arjuna asteroid belt, a collection of objects that circle the sun in orbits very similar to Earth's. Looking ahead, astronomers have calculated several future close approaches of 2024 PT5 to our planet. The next visit is expected on January 9th, 2025, when it will pass within about 1.1 million miles of Earth. However, its velocity during this approach may be too high for Earth's gravity to capture it again. A more promising opportunity might come in May 2084, when conditions could be just right for another temporary capture. While we say goodbye to this particular mini-moon, scientists remind us that such temporary captures are relatively common, with several typically occurring each decade. These events provide valuable opportunities to study near-Earth objects and better understand the complex gravitational dance between Earth and its cosmic neighbors. The James Webb Space Telescope is helping astronomers tackle one of the biggest questions in exoplanet research. Which distant worlds have atmospheres? A new study focusing on the super-Earth Gliese 486b is providing crucial insights into what scientists call the cosmic shoreline, the dividing line between planets that can maintain atmospheres and those that cannot. Located just 26 light-years away, Gliese 486b is about 2.8 times the mass of Earth and orbits a small, active red dwarf star. Recent Webb observations reveal the planet has a scorching dayside temperature of 865 Kelvin, measured with unprecedented precision to within just 14 degrees. This extreme heat suggests the planet has either a very thin atmosphere or none at all, as a thick atmosphere would help distribute heat more evenly. The findings are particularly significant because they help scientists understand how planets orbiting red dwarf stars, the most common type of star in our galaxy, might lose their atmospheres over billions of years due to intense stellar activity. This knowledge is crucial as astronomers continue their search for potentially habitable worlds, suggesting they should focus on more massive planets or those receiving less intense stellar radiation if they want to find worlds that have held on to their atmospheres. Finally, today, time to say congratulations. Scientists in India are celebrating the first major breakthrough from their Aditya L1 solar observation mission, the country's pioneering venture into solar studies. Using their advanced visible emission line coronagraph instrument, researchers have successfully captured and analyzed detailed data about massive solar eruptions known as coronal mass ejections. These powerful solar events can weigh up to 1 trillion kilograms and hurtle through space at speeds reaching 3,000 kilometers per second. When directed toward Earth, they can traverse the 150 million kilometer journey in as little as 15 hours, potentially causing significant disruptions to our technology-dependent world. The mission's ability to precisely track these solar storms could prove invaluable for protecting our modern infrastructure. These events can interfere with satellite operations, disrupt power grids, and affect global communication systems. By providing early warnings of incoming solar storms, Aditya L1's observations could give us crucial time to safeguard sensitive equipment and maintain essential services. What makes this achievement particularly noteworthy is the spacecraft's unique vantage point and capabilities. Its specialized coronagraph can observe the sun's outer corona continuously, providing uninterrupted monitoring that could help us better understand and predict these potentially hazardous solar phenomena. This advancement positions India among the select group of nations capable of conducting sophisticated solar research from space. And that's it for today. Thanks for listening to Astronomy Daily with me, Anna. If you'd like to catch up on all our back episodes, sign up for our free daily newsletter and stay up to date with the latest space and astronomy news. Head over to astronomydaily.io. You can also find us across social media. Just search for Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. I'll see you tomorrow with another episode of Astronomy Daily. In the meantime, keep looking up and let me know if you see anything unusual. Bye.